Hey there, Patriots. So in this video, we're going to talk about independent and dependent events, and we will find the probabilities of independent and dependent events by using formulas that I'm going to show you. So to understand independent and dependent events, we need to understand the word intersection. So the intersection of two outcomes, A and B, that's A and B, is the event that A and B both occur. So what we need to know, A and B both occur. Alrighty, so let's make sure that we write that down. Oops, let me know if I could write that correctly. Let me try that again. That A and B both occur. That's an intersection, an AND event. So for an example, choosing a car from a parking lot, see if it is black and an SUV. So my event is I'm going to choose a car, and the outcomes are the color and the type of car. So I want one car that is both black and an SUV. I want to choose one sandwich, and that sandwich has to have pickles, onions, and ham. So you can see the event is choosing the sandwich, but the outcomes are pickles, onions, and ham. And if I'm missing any part of it, that doesn't make me happy. An and needs all the parts. I need to be both black and an SUV. I need to have the sandwich needs to have pickles, onions, and ham. To calculate the intersection are ands. If A and B are independent, so we need these events to be independent, then the probability of A and B is the probability of A times the probability of B. The probability of one event times the probability of the second event. Well, I just use this important word, independent. Independent. Well, what is independent? Two events are independent if the occurrence of one event does not affect the probability of the other event occurring. So independence, the occurrence of one event does not affect the probability of the other event occurring. That means my outcomes don't influence each other. So here are some examples of independent events. Rolling a die, which would be event A, one of the events, flipping a coin. The die and the coin have no effect on each other. So the die and coin don't affect each other. Because no matter what happens with the die, what I get 1, 2, 3, 4, 5, 6, no one cares. That has no effect on whether I get a heads or a tails. Drawing a card from a deck and replacing it, the key word here is replacing it. Independent events, I replace it, and then I draw another card from a deck of cards. Both times we choose from 52 cards. So we're going to choose from 52 cards both times. Spinning a spinner multiple times. Each spin is its own event. Spinners have no memory. So if I was blue, 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 it doesn't matter what the next spin is because they are all independent of each other. Now, dependent events. Dependent means the probability of event A of event B, the second event, is affected by the occurrence of another event, event A. So dependence. Event B is affected by event A. So if I draw a card from a deck of cards, keep it. Keep that first card and draw another card. So event B has 51 cards to choose from. Event A had 52 cards. 51 cards for event B, 52 cards for event A. Your grade level and going to prom. Why? Because juniors and seniors are more likely to go to prom than freshmen and sophomores. It's not unheard of that freshmen and sophomores go to prom, but juniors and seniors go more often. So knowing what grade level you're in will help me determine if you're going to go to prom. And then how do I calculate this? By this formula right here. So the probability that event B occurs given that A has already happened. So the probability of A and B is the probability of A times the probability of B given A has already happened. So this symbol right here, probability of B given A has already happened. So that's what we're talking about. So so we're saying the probability of B given that given A has happened. So that's what this means. The probability of B given that A has already happened. So let's determine whether these events are independent or dependent. Does event A affect event B? Yusef draws a colored toothpick from a jar. Without replacing it, he draws a second toothpick. Alrighty, so my keywords here, without replacing it. So there are less toothpicks the second time around. Alrighty, so these are dependent. These events are dependent. There are less toothpicks for the second pick. There are less toothpicks for the second pick. The next one, Paula rolls a 6 on a number cube, a die, then flips a coin that comes up heads. These are independent events. Independent. And they're independent because the die, because the die and the coin have nothing in common. So no matter what happens with the die, that has no effect on the coin at all. Allie draws from a card from a deck of cards and replaces it. She draws a second card. So we draw a card, replace it, draw a second card. Because I replace it, that's the key right there. Because it's replaced, this is independent. We have 52 cards for both draws. And then lastly, having high cholesterol and diet. As a rule, these are dependent events. My events are having high cholesterol and what I eat. They're dependent. Diet can control your cholesterol. There we go. Boom. All right, so how are we going to check for independence mathematically? What's our formula? So if the probability of A equals the probability of A given that B has already happened, then we are independent. What I want you to notice when I'm doing this, probability of A comes second. B comes second. B's on top. You can think about this as a fraction, but I don't know if that will really help. Alrighty. So that's when we know that they are independent events. If either of these equations are true, we are independent. If the equation is false, we are dependent. And then use either equations. Both equations state that the second event is not influenced by the first event. So remember when we're looking at this, when we see, so this is always probability of second, and then we've given first. That's how these are read. Probability of the second event given the first event has already happened. Alrighty? So of course, if you got any questions, speak up. We're going to try a couple of these problems as we're going on. And we'll see you when we see you, Patriots.